Hi, my name is Edward Raff. I'm with Booz Allen Hamilton, working for the Laboratory for Physical Sciences. With my advisor, Dr. Nicholas at UMBC, we've been working on ways to try and fight malware and give analysts better tools using machine learning. Many of you at KDD likely recognize malware as an increasingly important problem for the same reasons I do. Computers are becoming pervasive and critical to our infrastructure, and increasing the damage that malware can do while also increasing the incentives for people writing it. When talking about the challenges with malware, most people think about software updates and installing antivirus. But we also need tools to help us explore our data, search for similar historical malware, or find malware with shared components. Essentially, we want a way to measure the similarity between arbitrary programs or binaries. This is a particularly hard problem for many reasons. For our use case, malware will often intentionally break formatting specifications and try weird or undefined behavior to obfuscate itself and thwart analysis. So it's not trivial to just parse a binary and get information about it that we can then compare. We want a way to do this comparison without having to really know or understand all these intricate details on how binaries are stored and programs are loaded and formatted. One tool to do this is the Normalized Compression Distance, or NCD. If you have two arbitrary byte sequences and you want to compare them to each other, you apply a compression algorithm to each of them separately and see how much they compressed. And then you take the two original sequences and you squish them together and you see how much they compress when you squish them together. If you get a large compression savings by putting them together, it means they had similar content, and thus the compressed size of them together will be larger than the compressed size of them independently. If the compressed size together doesn't get any smaller, it tells you there's no similar content. Now, NCD has a lot of nice properties, but in practice, it doesn't tend to work out so well, especially because using compression algorithms is very slow, so we can't scale this up to a lot of data. By taking some inspiration from how NCD is used in practice, we've developed the Lempel-Ziv Jaccard Distance, or LZJD. LZJD is simple to implement, orders of magnitude faster than NCD, and has better accuracy on a number of malware datasets and tasks. If this sounds interesting to you, give our paper a read for the details.